Dear students, this is Surwadi, your science teacher. Today I'll give you a brief explanation on chapter 4, Structure of the Atoms. In the previous chapter, you have already learned Dalton's atomic theory. According to Dalton, anything in the universe is made up of atoms. He clearly stated that atom is the smallest particles which cannot be further divided into smaller units. This is indivisible. Any substance, when we keep on dividing, as this will reach when it is no longer divided into smaller units. He stated this as atom. All around the world, scientists try to attempt the structure of this atom. And scientists discovered some very minute particles also coming out from the atom, which is known as subatomic particle. These subatomic particles are of three types, and those are electron, proton, and neutron. Electrons carry negative charge and protons carry positive charge, while neutrons doesn't have any charges. And it is also found that the mass of the electron is approximately equal to 9 into 10 to the power minus 28 gram, and mass of proton is 1.6 into 10 to the power minus 24 gram, and neutron is also almost equal to mass of proton. So when we calculate the ratio of mass of proton to the mass of electron, when we calculate this, we will get an approximate value equal to 2000, which means that mass of proton is approximately equal to 2000 times the mass of electron. That means mass of proton is 2000 times greater than the mass of electron. That is why mass of electron is considered as negligible. Now let us try to learn how two subatomic particles are discovered. First one, discovery of electron. In 1897, Sir J.J. Thomson discovered electron while conducting an experiment using a cathode ray tube. Now, what is a cathode ray tube? A cathode ray tube is a vacuum-filled tube which does not allow any air to enter into it. Inside the tube, on one side, a cathode is placed, and on the other side, an anode is placed. Cathode is a positive charge conductor connected to a negative charge conductor connected to the negative terminal of the battery, and the anode is the positive charge conductor connected to the positive terminal of the battery. An anode has a small hole in its opposite side of the tube. Its opposite side of the tube of the anode is coated with fluorescent material. So the behind screen is coated by fluorescent material. So in a dark room, when an electric current is passed through a gas, it high voltage in very low air pressure, he found out a stream of minute particles is emitted by the cathode in the small hole at the anode, allowed this beam of light to pass through it. And when this beam of light struck the wall of the coated fluorescent screen, when this beam of light hit the screen of this fluorescent screen, it starts to glow. The fluorescent material, the fluorescent screen starts to glow. From this experiment, he decided that this particle must come from somewhere within the atom. Towards from the cathode, it is emitted from the atom. By this experiment, Dalton's theory was proved incorrect, since Dalton stated that atom is the smallest particle. But from the gas atom, some very minute particles emitted from the cathode. So Dalton's theory proved wrong. Now let's take a closer look at what happened inside the cathode ray tube. When an electric current is passed, the electrical energy, when this electrical current is passed, the electrical energy pushed out some of the electrons from the gas atom. These fast moving electrons forms the cathode ray. It forms the cathode ray. Those are the cathode rays. Forms the cathode rays. This flow of electron from cathode towards the anode is called cathode rays. This is called cathode rays. This is how Sir J.J. Thomson discovered electron. Now come to the second subatomic particle, proton, the discovery of proton. In 1886, A. Goldstein, performing some experiment with a discharge tube, the same experiment performed by J.J. Thomson, containing perforated cathode. Perforated cathode means cathode with several number of holes. He observed that when the cathode rays are traveling from the cathode to the anode, when the cathode rays are traveling from the cathode to the anode, there are some other luminous waves. That means, like cathode rays, there are some rays also emitted from the anode and travel from anode towards the cathode, and he called this as canal rays. These rays, A. Goldstein termed it as canal rays. In Thomson's model, Thomson's experiment, the rays which is emitted from the cathode, he termed it as cathode rays. While in Goldstein experiment, the rays which is emitted from the anodes towards the cathode, he termed it as canal rays. Because these rays pass through the holes of the cathode, he named this as canal rays. In his experiment, he found that these rays are made up of another subatomic particle. These rays are also made up of another subatomic particle, and later this particle was labeled as proton by Rutherford, not by Goldstein. The name was termed only by Rutherford. A.G. Goldstein discovered only a rays which is emitted from the anode towards the cathode. Later on, these rays was termed as proton by Rutherford. These rays are also known as the anode rays, as it emerged from the anode towards the cathode. Now the third subatomic particle is the neutron. Both electron and proton was discovered in the late 1800s, and this neutron was discovered after a long gap. In 1932, J. Jedwick discovered another subatomic particle which had no charge and a mass nearly equal to that of the proton. Mass of this neutron is exactly equal to the mass of the proton, as I have already stated earlier. Neutrons are present in the nucleus of the atom. Except hydrogen, almost all the atoms contain this neutron. In general, a neutron is represented as letter N. The mass of an atom is therefore given by the mass of the proton. Mass of an atom were calculated from sum of the mass of neutron plus mass of proton, because mass of proton is almost equal to mass of neutron. And why we are neglecting electron? Because mass of electron is negligible, because mass of proton is 2000 times larger than the mass of electron. So it is important to know how these electrons and protons are arranged within an atom. The first attempt to describe the internal structure of the atom was done by Sir J.G. Thomson. He proposed the model to be similar to that of Christmas pudding or a watermelon. A Christmas pudding or a watermelon. In watermelon, he proposed that, let me explain the postulates of his model. An atom consists of positively charged sphere and electrons are embedded in it. Like in watermelon, the seeds are embedded inside the red edible portion. This is considered as the seeds of the watermelon. Inside the watermelon, this is the edible portion, the red edible portion. He considered it as the positive charges. In the seeds, he considered it as the electrons. That is why an atom consists of positively charged sphere and the electrons are embedded in it. Electrons are embedded in it. Those are the electrons. In the remaining portion, he considered it as the proton. The second postulate is the positive and negative charges are equal in magnitude. Both positive and negative charges are equal in magnitude. Suppose if there are 100 number of electrons, then there are 100 number of protons. So atom as a whole is electrically neutral. Although he explained that atoms are electrically neutral, the results of the experiment carried out by other scientists could not be explained by this model. So after his experiment, Ernest Rutherford done some experiment this on Rutherford's model, Thomson's model. In his experiment, he used fast-moving alpha particle and a thin coil foil and a detector screen. Why he used alpha particles? He used alpha particles because alpha particle is a positively charged particles having 2 units of positive charge. Alpha particle contain 2 positive charge and 4 units of mass. It is actually a helium ion. This alpha particle is actually a helium ion containing two positive charge. Alpha particles are emitted by radioactive elements like radium, polonium. These fast-moving alpha particles have a suitable amount of energy. That is why he used this alpha particle. The second one, coal foil. He used coal foil because coal can be incredibly beaten into thin sheets so that all the atoms present in the coal are uniformly distributed. That is why I selected this coal foil as this element. And he also used as a detector screen in order to detect the alpha particles. Since the alpha particle have suitable amount of energy, they can penetrate to some extent. They can penetrate, this alpha particle can penetrate this coal foil. Have placed this thin sheet of coal foil at the center of the circular detector. This is the circular detector. Have placed the coal foil at the center. The detector will flash. The detector will flash if the alpha particle hit on it. Rutherford knows that the alpha particle have enough energy to pass through this coal foil and hit the detector screen. But the experiment become twist and give totally unexpected results. So what are those results from his experiment? Most of the fast-moving alpha particles pass straight through the coal foil. The alpha particle, fast-moving alpha particle, directly penetrate to the coal foil. Some of the alpha particles were detected by the foil by small angles, by some small angles. Those are some detections which were detected, deflected by certain angles. Surprisingly, 1 out of every 2000 particles appeared to be rebound. Suppose this is the coal atom, the thin sheet of gold foil where the atoms are uniformly spread. Almost all the alpha particles penetrate through this coal foil. Out of every 12,000 alpha particles, one of them show deflection. One of them show deflection. That means almost all the alpha particles penetrate through the coal foil, except few of them show small deflections. So from this observation, he postulated his model. So the postulates of his model are: most of the space inside the atom is empty because most of the alpha particle pass through the coal foil without getting deflected. You have already know that like charges repel each other. Only the unlike charges they attract each other. So consider this is the proton. Proton carry positive charge. In alpha particle also carry positive charge. So positive charge when hit the positive charge, it shows deflection. In most of the space inside the atoms are empty, which shows that most of the space inside the atoms are negative charges, electrons. The protons are present only at a small region inside the atom. Very few particles were deflected from their path, indicating that the positive charge of the atom occupies very little space, because out of every 12,000 particles, only one of them show deflection, which shows that protons occupy a very little space inside the atom. Third one, a very small fraction of the alpha particle were deflected by 180 degree in the same direction in the same path in opposite direction, indicating that all the positive charge and mass of the coal atom were concentrated in a very small volume within the atom. So from the data, he also calculated that the radius of the nucleus is about 10 to the power 5 times less than the radius of the atom. Radius of the atom. The radius of this nucleus is 10 to the power 5 times less than the radius of the atom. So on the basis of his experiment, Rutherford put forward the nuclear model of atom, which had the following features. There is a positively charged center and an atom called the nucleus. This positive charged center, he named it as nucleus. Nearly all the mass of the atom reside inside the nucleus because the remaining part is covered by electrons and protons are found in the nucleus, and mass of the atom is concentrated in the nucleus because mass of the electrons are almost negligible. The electrons revolve around the nucleus in circular path. The electrons around the nucleus, they revolve in circular path. The size of the nucleus is very small as compared to the size of the atom. But there are certain limitations on his model, the limitations of Rutherford model, because he could not explain the stability of the atom. As he already stated that the electrons revolve around in circular path, but when any electrons revolve in circular path, it will undergo acceleration, and once it is accelerated, it will lose its energy, radiate its energy, and fall into the nucleus. Hence, the atom will become unstable. So the actual structure of the atom was proposed by Sir Niels Bohr. Niels Bohr stated that an atom is made up of 3 particles, and those particles are electrons, protons, and neutrons. The number of proton and electron in each atom is equal. This makes the atom electrically neutral. Number of electron is equals to number of proton in an atom. That is why atom become electrically neutral. The proton and neutrons are present at the center of the atom, which is known as the nucleus. The nucleus is positively charged due to the presence of the proton. Now let us see the postulates of his model. Only certain special orbits known as the discrete orbits of electrons are allowed inside the atom, which shows that electrons are revolved around the nucleus only in certain discrete orbitals, only in selected orbitals, not in random order. While revolving in discrete orbits, the electrons do not radiate energy. Since they are revolving in their own path, they will never lose its energy. These orbits or shields are also called as the energy levels. The orbits or shields are represented by letter K, L, M, N, and so on. When represented by letters, they are represented by letter K, L, M, N, and so on. And when they are represented by the numbers, N equals to 1, 2, 3, 4, and so on. So the first shield, the innermost shield, is called K shield, the first shield, L, second shield, M, third, N, fourth, and so on. So Bohr's model of atom was accepted as the actual model of atom, as he explained that electrons are revolved only in certain orbits. So when electrons revolve in their own orbits, they will never lose its energy, so that the atoms becomes stable. In the distribution of these electrons as K, L, M by letters or by numbers 1, 2, 3, and how these electrons in an atom are distributed. The distribution of electrons in different energy levels will come out in the next video. Thank you.